The solar configurator of ObViewSly is now available online as an additional module of the online GIS viewer ObViewSly. Our solar configurator differs significantly from a classical solar cadastral register because it allows precise planning for specific objects. Existing roof structures, as well as neighbouring buildings or vegetation influencing the solar radiation, can easily be taken into account. The basic data of the solar configurator is current geodata in the form of vertical and oblique aerial images. The online viewer, ObViewSly, with its standard functions, allows an elegant navigation through the data file. The use of oblique aerial images enables a photorealistic mapping of building facades, as well as all other topographical elements. Thus, the actual situation on the ground can be reproduced from all cardinal directions. The solar configurator can be deployed after creating a virtual world from the aerial image data. A free-moving 3D view is thus generated. The object on which the solar energy system is to be mounted is selected using the navigation functions of ObViewSly, such as zoom, pan, or the address search. The existing roof structures can be seen very well here. The configuration of the solar energy system starts with the selection of the intended solar panels. One of the 4 classic module types in various sizes and efficiencies is in place here. A solar panel is first mounted on the roof. The inclination of the panel is automatically adjusted to match the actual roof inclination. If necessary, the already positioned panel can be moved again. Additional panels can now be mounted in several ways, either by manually placing a new module or, as shown here, by simply adding panels in whatever direction. By selecting multiple panels with the Control key, they can be grouped and positioned together. Unwanted shading can be checked for each of the seasons in an initial analysis by simply selecting a month. In a short report, the next step is the calculation of the expected yields based on the actual module geometry, as well as the initialization of a profitability check. The short report provides information on the following matters: the location of the object on a map segment, the geometry and surface area of the solar energy system, the solar radiation in different seasons, radiation losses due to shading, radiation energy, the usable electricity in kilowatt hours according to the efficiency of different module types, the saving of CO2 per year, and the heat output when using solar thermal energy. The profitability check provides information about when the solar energy system can finally pay for itself. Different scenarios can be taken into account. On the first page, the annual consumption of electricity is defined. Selection aids are offered for this. For example, a 3-person household with 5,000 kilowatt hours is suggested. The values can be adjusted manually. The self-usage of the produced electricity can be defined. The standard is about 30% for a private household without any intermediate storage of the generated electricity. The rest of the electricity which cannot be consumed by the user is compensated for by the feed-in tariff. Electricity costs and feed-in tariff are also stipulated here. Fundamentally, reasonable rates are suggested, but these must be adapted to the customer's own contracts. The costs and financing of the solar energy system are defined on page 2 of the profitability check. Reasonable market prices are also suggested here, which may, however, differ from any real offers. The result of the profitability check is the previously mentioned short report, complemented by the following information: specification of the solar energy system with surface area, model, and costs. electricity demands and specific costs for consumption and feed-in, and definition of the financing. The result includes a yield calculation and a payback table, which shows as of which year the intended system can generate a profit. Diagrams of electricity consumption and CO2 savings are also provided. At ObViewSly, you can test the solar configurator for yourself, so try it out.